This conference will now be recorded.
Yeah, so recording is on. So hi, Mirjam. Welcome again to HL7 Virtual Connectathon for India. So today we are going to have a profiling session from you. So over to you.
Yes, correct. Well, thank you for having me again. And well, let's get started. As said, I have 1 hour. So I have a couple of slides first, and then of course we will have some time for questions as well. And I will also try and do a small demo to show you to start with profiling, and hopefully that can help you get started with your work. So, well, this is again me, my details on here. I'm part of the Firely organization and have been part of the FHIR team since 2012, actually almost since the beginning of when FHIR originated. And these slides, they are available on the bit.ly link that you see on this slide as well. And they will be available for another 2 weeks or so before I take them off again. So if you want to, you can just go to that link and then download the PDF for today. And the one that I did previous to this session on Tuesday is still on there as well. So feel free to just download that one, and then you will have all of the information. So this is a slide that I presented on Tuesday as well. Firely provides tooling and software for you to use in regards to the FHIR specification. And we have a whole FHIR ecosystem, but the main thing that we are going to focus on today, of course, is this part here for the profile authors. So we are going to take a look in the demo, at least, at Forge, and then we can also take a look at Simplifier in order to publish the work we've done and collaborate on there. So that's the part that this presentation focuses on. Today we will take a look into why we would need profiling, and then I will show you a couple of examples of things that are in the FHIR conformance layer. And then we will move over to doing the real work, or at least explain a little bit more about profiles and extensions. Packages is also just a short topic that is in this presentation. Remember, this is meant to be an overview as well. And then we finish with a registry and a slide where you can find some tooling. There is also a slide attached that has a link to an online tutorial if you want to continue after this session to start creating your own profiles and have some guidance there. Then you can take a look at that particular tutorial to see what you can do. So of course, first, why would we do this? Why would we need profiling? And actually the answer to that is an easy one. We have the FHIR specification. The FHIR specification is meant to be a specification that can be used worldwide in all kinds of healthcare contexts and use cases. But since it is meant to be useful in all of those contexts and use cases, it also means it can't be too specific, because if the specification was too specific, then there would be countries or organizations that would say, we can't use this specification because there's all kinds of things in there that we cannot use or cannot work with, and then they would not use the FHIR specification. And of course, the whole idea of FHIR is that we are interoperable worldwide. So what we need to do is have a mechanism where you can use the specification, but also tailor that specification to your specific needs without becoming non-FHIR compliant. So we keep within the FHIR specification. We will always generate valid FHIR data. And then that means that the whole world can work with it. But for our own use case or context, we have described any extra adaptations, any extra requirements and needs that we have for that use case or context. So we need a way to do that. And that is what we can do with the FHIR specification. So we can use resources within FHIR in order to describe things like which resources we have, which terminologies we are using, how we can do some mapping if we have our own data model to something else, how we can do that. And there's conformance resources, as we call them, for all of these kind of things. It is important to have this in conformance resources because a conformance resource means that you will have a structured way of defining those extra adaptations that you have made. And if you have a structured thing, then that structured thing can be used to share at least your work and have other people look at your structure. And also it can be used, for example, to generate a UI or create a code or have validation run against those structures. So it's important to be able to do that. And I will show you how FHIR can help you with that. So all of those structures, we call them part of the FHIR conformance layer. And well, by now you might have played around with a couple of FHIR resources, but usually people start out with just looking at patient, looking at observation, things like that. And this part is about those other resource types that are available. We have categorized them a little bit in a couple of categories here. So what we are going to focus on most in this session is the content. We are going to use something called a structure definition resource type in order to create our profiles and our extensions. But you can also define terminology things. So you can create code systems and value sets, use concept maps to map between code systems. Also, you can use operational type of conformance resources, and we also have something, well, a bit miscellaneous, other things that you can also do. A couple of these resource types will be on the next couple of slides to give you a little bit of a better idea of them. But what is important to know is that the whole FHIR specification is defined in such conformance resource types as well. So if you look at one of the FHIR core data types or one of the FHIR core resource types, then there will be a structure definition defining that particular structure. And if you use a value set from the standard FHIR specification, then there will be a value set resource available to take a look at. So all of those conformance resources, you can find them inside of the FHIR specification as well. And well, at least for us at Firely, and I know for a number of other organizations as well, those structures, they lead us into using the FHIR specification. We do not look at any Excel sheets where you also might sometimes find some useful information. We do not use schemas and schematrons, even though they are still available to you if you need to use them. We use the FHIR resources that contain all of these definitions. You can download the standard FHIR specification with all of those conformance resources from the downloads page that I've mentioned on this slide. Now, that structure definition I mentioned is one of the most widely used ones because they are used to define the data structures. As mentioned, the data types and resources that are in the FHIR specification, but also if you want to make your own constraints on that, then you will use those things as a structure definition and create your own structure definition for what we will then call a profile. Also, structure definitions are used when you create extensions or, for example, when you create your own logical model that will result in a structure definition as well, because it defines a certain structure. In the list for operations, we found operation definition. And if you have looked at the FHIR RESTful interactions that are available to you in the standard FHIR specification, you might know that you can append a dollar and then the name of an operation at the end of the RESTful URL in order to perform one of the FHIR operations. Now, of course, those FHIR operations that are in the standard are defined in a structure. And in this case, then that will be the operation definition structure. But also if you create your own operations, because in your use case, you have the need to do more than just simple read-write access to your system, then you can define your own operation in an operation definition. And of course, it still has to be implemented, but then at least you will have the description for implementers to know what they need to implement. Also, search parameters have their own structure. So if you look at the standard FHIR website, at the bottom of each resource type page, you will have this whole list of search parameters that are defined for that resource type. Now, sometimes you will need less than there is in the list. And that just means that you don't implement support for the rest because, well, they are not useful to you. Other times you might find that there are elements within that resource type that do not have a standard search parameter attached to them. In that case, you can create your own search parameter, and then that is a definitional type of thing again, but tooling can consume that search parameter definition in order to then implement support for that particular search parameter. This is something that if we have time, I can show on our Vonk server, where I can upload the search parameter resource to that. And then as of that moment, Vonk is capable of indexing on a search parameter. But I will at least show you the structure of that search parameter so you will have an idea. There's also something called a capability statement. That resource type is used to define what kind of capabilities a certain system has. Each FHIR RESTful server has to be able to provide a capability statement upon request. So if you call your server a FHIR RESTful server, then you have to be able to well, generate this, and whenever it is asked, then you will have to send that as a response. So that is one way. This will then describe the capabilities of your software implementation. Another thing you can do with capability statement resources is describe the requirements that you have for your own use case or context. It will be probably a limited list because, well, your use case or context will work with a limited set of resources, with a limited set of interactions and operations and search parameters. You describe them in a capability statement resource, and then a developer can take a look at that and will know exactly what they need to support on their system or what can be expected of any server that is implemented accordingly. So it can be the real capabilities of a software or a system, or it could describe the requirements that you have. Another one that is interesting, I think, is the structure map resource type, because that structure map can create the relationships between two structures. And with a structure map resource, you can then map from one structure to the other. This is also based on the FHIR mapping language, which is part of the FHIR specification. You can take a look at that. But this makes it possible to transform data. So if your system has implemented this and you have a set of good structure map resources lying around on there, you could, for example, send in an HL7 FHIR message. Then the system will use their structure map to create a FHIR resource out of that, or FHIR resources, and then it can continue on working with those FHIR resources. So that could be a really powerful thing to have if you have good structure map definitions, at least. Well, then, when you have created all of your conformance resources, it is also important for developers to be able to say what to be done with it. So I'm hearing an echo on the line, so I was a bit distracted there. So when you have created all of your conformance resources. Oh, I think I am hearing myself.
Mute yourself, please, Mirjam. I muted everyone else.
Oh, okay, thank you. Yeah. Okay, so you have all of your conformance resources, but then it's important for someone going to work with your use case or context or connecting with that to be able to know what to do. And that doesn't necessarily mean just only looking at profiles, extensions, and the other conformance resources. Sometimes you will need a little bit more of a description around that, and that is what you can do in an implementation guide. An implementation guide itself could just be a website or a document that you have generated to hold all of that implementation guidance, that extra documentation. But it could also be done within an implementation guide resource, where you link from that implementation guide resources to the other conformance resources and to the specific HTML or Markdown pages that you have that describe the rest of the documentation. If you create a conformance type resource, then all of them will get something we call a canonical URL. In my opinion, that is a really important thing, because it will be the unique identifier for that conformance resource structure that you have created. So the author of the conformance resource is the one that's responsible for creating that particular canonical URL. It will take the form of a real URL. So I have 2 examples on there, and they will be unique, and they will be that particular identifier throughout the whole life of that conformance resource. So it will never change anymore as soon as you have published your conformance resource. That's why it is important to take a look at what you put in there. And usually it will be something like your own domain for your organization. You could include the word FHIR in the URL if you wanted to. But usually what people do at least is end it with the name of the conformance resource. So in this case, that would be both structure definition resources, and then a name that you would give that particular conformance resource yourselves. So that is just a convention. It is not mandatory to use that name of the conformance resource, but it makes it more clear to know what kind of resource type you're talking about. Other than that, what you do not have to have is a server that can answer to this particular link. So if I would click on the bottom one, I would get nowhere, because that FHIR.elp that we have, that is just a creation of ourselves, and that is not a real server anywhere. So that is not a mandatory thing. You will have to have a unique identifier on your conformance resource, but that URL does not need to be retrievable. Okay, so in the meantime, I did see a question from Aditya that where it's asked, what is a logical model and how is it different from a normal structure definition, I think you mean. So a normal structure definition will always be one of the FHIR types. If I create a structure definition as a profile, that will mean that I take one of the existing types and create a profile on top of that, make my constraints. A logical model is a standalone thing. I could create a model of every concept that I would have in my head. And sometimes you see that organizations, HL7 in the Netherlands, for example, together with another organization in the Netherlands, they have a means of creating logical models, not in FHIR, but in a different tooling. If you would have that, then you could also transform that into a FHIR structure, into a FHIR logical model. If you have it as a FHIR logical model, then you will have a FHIR structure definition resource, and then you could use a structure map in order to map your own logical model, your own concept, as it were, to any of the real FHIR concepts. Logical models are just that, a model, and they are not meant to be instantiated, so there's not meant to be a resource instance that is according to that logical model. Where, of course, the normal FHIR resource types, they are meant to be instantiated, and you have resource instances of them. Logical models can then be reused, of course. So if you once create a logical model, then you can reuse that, in this case, of course, to map your data to FHIR. But later on in the future, when there might be a new specification, you could take that same logical model and then map that onto another standard. So that is a useful thing to have, because it has your concepts. So let me continue with this part, and then I will check the questions again. So profiles are constraints on standard FHIR core data types or core resources. So you take one of those and then you constrain them, restricting them further, making them more specific. You could also make use of an existing FHIR profile that someone else created and then make extra constraints on top of that. We call that derived profiles. Sometimes the term profiling also means creating an implementation guide or creating all of the conformance resources in a conformance package, as it were. But if I say I'm going to create a profile, then I mean one of the first three things there. This is a slide that details that layered profiling. In the end, we will have a small set of core profiles. We have them already, and all resources will conform to those core profiles. But well, if you go more and more specific, you will see that we'll get more and more profiles. So in the end, we will have a large amount of organizational or use case specific profiles, but a limited set of resources will conform to them because they will be more specific than the core profiles, of course. When you are going to create your own structure definition, your own profile, as I mentioned, you will have to think about that canonical URL and put it in there. There's also some other metadata things like the name and the title. You can provide it with author and copyright information and things like that. And also it will list what the base profile is. So on a profile, it will list the base profile. If you create a logical model, it's of course not based on anything, so it will not list that base profile. So that's a small difference there. Within that structure definition, the real work, I always say, is in the element definitions. This is a block of information within the structure definition resource type, and that will list a data element. So for example, if you look at the patient resource type, you know that a patient has a birth date, and there will be an element definition that details that patient.birth date field. Naming it birth date, giving it a cardinality for patient that would be 0 to 1. You can also set default values in there or fixed values. You can set terminology bindings in there. So anything that you might want to indicate about that data element that goes into that element definition. Well, you might be able to imagine that this gets very complex very quickly. So I would never create a structure definition by hand. I do that with a lot of other resources. If I create a patient, I just open up my text editor and create a JSON or XML patient resource, copy something from the specification and then change it to my needs. I would never do that with a structure definition resource because it gets very complicated and it's easy to go and make mistakes. So I would always advise to use a tool that can generate such a structure definition correctly for you. Now, of course, if we have a profile, then it could be that you have a resource instance and you want to say, okay, this resource instance conforms to that profile. So let us look at this observation resource here. We have an observation resource, and I might want to indicate that this observation resource conforms to an LDL cholesterol profile that I have. Conforming to that profile, or at least indicating conformance, is done in the meta part of the resource, and it's called a profile tag. I will just list that canonical URL in there in the profile tag, and that will mean that I claim to conform to that profile. Then, of course, we could try and resolve that on the server if we want to know whether this claim is true, or, well, hopefully it is retrievable, or we could reach out to another repository as well. If we have that structure, then we have a structure definition that says, okay, these are the requirements for this particular LDL cholesterol observation, and we can use that to validate the resource data. Because the claim itself is not enough. You usually also want to validate whether that claim is correct or not. Well, as mentioned, you can also use other registries to find your profiles. Okay, then we have extensions. As I mentioned, they are also a form of a structure definition. They are less complicated than a profile structure definition, but they will always well, end up in a structure definition as well. And extensions, they are used in order to define extra elements. Perhaps you have had an introduction where they have detailed that the FHIR specification implements or specifies for 80% of cases. So they take an 80-20 rule in order to know or decide whether to put a data element on a resource type. That means that sometimes you lose out on things that you might always put in that data. For example, in the US, they like to have race and ethnicity on there, or even make that mandatory. So in the US core profiles, what they have had to do is create extensions for those particular data elements in order to put them on the patient resource, because it's illegal in other countries sometimes. So the FHIR organization, HL7, they said we can't put race and ethnicity on the standard FHIR patient, because that would mean that we would close off our standards to a lot of a big part of the world where they cannot use that. So whenever you find something like that, where the work group has decided they cannot put that on the real FHIR data, or if they just say, okay, it's not part of the 80%, so, well, bad luck, then you can create an extension, and with that extension, you can add in extra data on your FHIR resource. Usually you combine this with another profile. So you create an extension, you create a profile, and then you make sure that that extension is used within that profile. Again, it will get a canonical URL, but you will also have to detail where this extension can be used. So if I create a birthplace extension for patient, I will have to say, okay, this can be used on a patient resource. I can also create extensions that can be used on multiple resource types, and you can extend every part of the FHIR specification, almost every part. So you can also define within the FHIR hierarchy exactly the path to the place where the extension can be put. When you are going to create extensions, we would like you to encourage you to make them as generic as possible, because that would mean that you can reuse that extension across other profiles as well. Of course, some extensions will just be very specific and only be used in a certain place. And then, of course, you can be specific. But for other cases, please just take a look at it and find that balance between very generic and very specific. So let me just take a quick look in the meantime to the questions there. So I do see see a question coming in, and let me know if I have missed anything, because the chat, of course, moves over to other people as well as when you put in extra questions. But one of the questions I see here is, can I validate cardinality restriction in a structure definition using a FHIR validator? This is a good point, because the next sentence actually tells me something, that you want to do something that you cannot do. If something is mandatory in the base FHIR specification, you cannot make it optional, because if you would make it optional and then create a resource instance, it would not be valid against the main FHIR specification. And the whole idea of FHIR is that every resource will conform at least to the FHIR base specification. So you cannot make mandatory things optional. You can make optional things mandatory, and that in the last case, of course, a FHIR validator will give an error if you have a mistake in the resource data. So if you don't have the data on there, which is mandatory, then a FHIR validator will complain. But the other way around is not possible. So, okay. So packages.
So one more question, Maria.
Yes. That I missed. Yeah.
If we want to constrain one element in one data type for one resource, can we do that in structure definition of that particular resource only?
Let me see. You can do it in two places.
Can I elaborate on this question?
Go ahead, please.
So, for example, patient has human name, and human name has various other elements like given name, text, etc. So can we make the change over there in the patient profile, or do I have to go and change the structure definition of human name, make the change over there so that it gets reflected in patient?
Depends. You can take both approaches, but it depends on your use case what would be most useful. So if you say that in all cases, also for practitioner, for example, or other resource types, that human name will have these restrictions that you now want to decide upon, then I would profile that in the human name data type, and then make sure to link from patient to that human name data type that I've profiled, and from practitioner and from any other resource that uses human name, I can point to my own profile of human name. If you say this is only for patients, then I would just create a patient profile and go to the patient name and then make my restrictions there. Does
So
that make
essentially
sense?
a global or a local change.
Yes, and that depends on what the view is on your other resources that you have. And of course, well, you might also want to create multiple patient profiles depending on use case. If you take that approach where you put it in the patient profile, then that would mean that you would have to make sure that it ends up in all of those patient profiles as well. Of course, it can be done with layered profiles then, that you make one overarching patient profile with that change in it within a human name, and then derive from that, and you will have the change immediately. But yeah, I know in the Dutch profiles what they have done is they have made profile on the human name data type, because those changes that they have made, they hold true for patients, for persons, for practitioners, for all person-related FHIR resource types that can take a human name. So they didn't want to put it in everywhere, and they have created just one profile on the human name data type. But as I said, it depends on your focus.
And then the data type profile which they modified, they had to mark it as a target profile in each of patient practitioner.
Yes,
right?
Correct. You will still have to connect that data type profile to the patient profile or the practitioner profile you create, and that's done with that target profile, yes.
So which is not the case in patient profile right now. A patient profile does not, the target profile of human name is not pointed to the human name structure definition, right?
It's pointed to the standard human name structure definition.
Yeah, but the target profile link is not present in the patient human name link.
You might not see it, but it is there. But I can see if we can take a look at that when I show you the Forge tool to see what it looks like. Okay.
Sure, thank you.
So just a couple more slides here, if you don't mind, and then again, I'm available for some questions. So packages, we can create all of those FHIR conformance resources, but in the past, when we've done that, we have seen that there could be problems with versioning. And what you want to have is one set of FHIR conformance resources that belong together, that all work nicely together. And that can be done by creating a package out of your set of profiles and other conformance resources. It makes it easier for tooling when you can just point to one package and you will have the complete set. It makes it also easier for communication that you say, okay, we are on the profile set 1.0 or on the profile set 2.1, and you will always know that you have a set of resources that works together correctly. So I will not go into much more detail than that. There's a whole lot of other presentations about packages, but what I can detail is that we have the option in SimpliFHIR to create packages. So if you have a project, you can then create a package out of that project, and it will just be kind of a snapshot in time for the set of resources you have right then, and then you can create that package, and well, distribution of that package can then be done. And tooling like the Forge tool can then also consume those packages. So in Forge, you can point to a particular package that you want to use as your base, and then you can just load that into the Forge tool without having to separately download all of the profiles and other resources that are part of that. So it makes it a lot easier to, well, also work with and then have your dependencies on a particular package. Well, that brings me to registries and tooling, where we have an official HL7 FHIR registry, which is registry.phir.org, where you can find all of the HL7 core profiles, and you can also find HL7 affiliates and other profiles on there. It is powered, by the way, by SimpliFHIR. So in the end, all of these things have to have a project on SimpliFHIR in order to then be able to be put on the HL7 profile registry. There's also a registry for implementation guides that you could take a look at as well. And as I said, SimpliFHIR is the driving force behind the HL7 FHIR registry. And we have made it a point that we put all of the standard structures on there, but also HL7 affiliates can have a project on there. If you are an organization that wants to have a private project, that is possible on SimpliFHIR, even though it is meant to be a public platform. If you have a free account, you can create one public project and then make use of that. But of course, it means that everyone can see what kind of work you're doing on there. SimpliFHIR can also help you with validating against profiles. So you can put in a resource instance, an example, and then validate that example resource against the profile that you have. And then you can also create the implementation guide on SimpliFHIR if you want to, which is, well, somewhat nicer than doing that in an editor, because it will have a nice IG editor with a nice, well, you can see a little bit of help with markdown links and things like that. So it is well, kind of nice to do that instead of having to fill in all of the markdown yourselves in an editor. So this is a list of profiling tools. I do not say that this is the complete list of tools, but just an example of tooling that you could use. We are going to use the Forge tool to do profiling, but if you do not want to, there's other options there as well. For example, Trifolia or the web-based ClinFHIR, which you can then use to create your profiles on. Okay, so that was my main presentation there. And I do see another question. How can I validate a profile using $validate against custom specified? Okay, well, that's a little bit of a couple of things in one thing. So if you want to validate against SimpliFHIR.net, then I would suggest that you go to SimpliFHIR.net and use the validation mechanism there. I don't know if we have opened up the SimpliFHIR programmatical API to support $validate on there, which is the FHIR operation to perform validation. I did show on Tuesday an example where I had my Vonk server, and then that Vonk server was loaded with my SimpliFHIR project, and I could do a $validate to my Vonk FHIR server to be able to validate a particular resource against that. So you will not necessarily have a custom specification.zip, because the specification.zip that we use is just the standard FHIR specification. And you cannot change that in the tooling underlying that. But what you can do is create those profiles and then feed them into SimpliFHIR or feed them into the Vonk FHIR server and then make use of them. So without having to change that specification.zip, you can just add all of your profiles and other structures to the server or to SimpliFHIR, and then they are capable of using them for validation. So I hope that answers your question. And then I have another question. There's a use case where different set of element constraints are required, post, search, and get of a resource. And then is it advisable to create different profiles of the same resource in such a case? It could be useful to have several profiles in order to just make it clear what is expected on a post, but also what is expected that you get back on a search. If they are really different, I would not necessarily expect when I send the patient in according to a profile that when I retrieve it again, I would get a patient according to a different profile. So that looks a little bit like, well, what are you trying to do exactly? So perhaps I do not necessarily understand the use case there, but it could be done. And then, of course, in your implementation guide, you would detail the specific patient profiles or the specific resource type profiles that you have in order to have the developers or the implementers know what they can expect. But you can have several profiles on one resource type for specific parts of use cases if you need them. So that's perfectly okay. And the server can support multiple profiles as well, of course. So you could say, okay, I support the HL7 India profiles, but I also support my own organization profiles that might or might not be derived from those. So that's an option. So
question,
yeah, so yeah.
Question, Mirjam. So
Yes.
if a server supports multiple profiles for a resource, when you do a get, what does the server return?
Well, usually the server returns the resource as it is stored, so as it came in and then is stored on the server. Yes, so that would be my first thought there. But if it's important for you to have any control over that, you should do things either with having an operation instead of a normal get, and then making sure that someone asks for a specific resource according to a specific profile, or you could make use of multiple endpoints, but then and then depending on the endpoint that people use to get something, you could generate that resource from the data you have according to the profile that is for that particular endpoint. Something like that could be done. Of course, usually I would hope that when you create multiple profiles that they somehow relate by being derived profiles, and then it's easier because you could get in a more generic one or get in a very specific one for the use case, but always send out the more generic one. That could be options there.
Thank you.
So yeah. We should take a look at a specific use case that you might have, and then you can take a better look at which approach would be best. But there are several options, of course. That's the problem with FHIR. It gives you a lot of options, and then you still have to do work, which is why we have implementation guides and such in order to get to the real use case or context that you want to implement.
Yeah, because I see that problem happening. If we have a national level, say, a registry of patients, and it has state level profiles, and each state has their own, say, some adaptations of the profiles, but everyone supports, sends to the central repository, and that can support all the profiles. Then, depending on different states in India, there can be different patient resources, supporting different profiles on the central server.
Yes.
And then when you do a get, the get confuses which one to give.
Yes. So what I would think in the Netherlands, you would have a Dutch patient profile, yes. And then if you have a specific organization within the Netherlands, they can make use of that Dutch profile. So they take that as their base profile. Instead of the FHIR patient, which is too optional, we take the Dutch patient, and then we create our own Dutch organization patient profile. Another organization might do the same. In the end, they will all conform to that Dutch patient profile. So my registry is only needs to implement support for the main profile. So if you can have that happen in India as well, that you make an HL7 India patient and say, okay, doesn't matter what you do, if you're an organization or a region or a state, you always have to conform to that HL7 India profile, and then your registry can work with that. Does that make sense?
Yes, it does.
Yeah. And of course, that will mean that if you have a very specific organization or state that says this is mandatory for us, but it's not mandatory in the HL7 India patient, and someone requests data that is not conformant to that particular organization profile, you will have a mismatch, but that's mismatch between organizations and not on the India level. So yeah, so there is another question in element definition pattern, and that is a very specific question there. Is it mandatory to choose that X as the data type? Yes, you would, in that pattern, you would choose what kind of data type that pattern is for, in order for a validator to be able to check against that particular pattern. Actually, I do know that there will be some changes, or there are some proposed for R5, where that pattern field might get some more attention, or perhaps even we move away from that and do more with FHIR path. But that is a little bit beyond what I can detail today, how that particular thing works. Sure. But Adika, you know our details, so you can always reach out to us to see about that.
Yeah, so actually, I understand the first part. X has to be replaced by the data type. The question is it mandatory to replace it by the data type of the element we are constraining, or we can choose our own data type, like birth date? So do I have, when I'm writing a pattern, do I have to use the date as X, or can I have my own data type? Because the point is, if I want to constrain date with some regular expression, or let's say identify dot value with regular expression, then I have to choose my own data type. So is that allowed? That's what I wanted to understand.
Well, if you put it on a particular element, usually that element already has a data type, so it should be Correct. That data type that you can only use the pattern for. I'm not sure exactly, you would not change that. You would have the tooling do that for you and then see in your structure definition what it results in. But okay. Perhaps we could take that question offline, and you could sure, email me with some details, and we can have a discussion there, just so we do not confuse everyone else who is perhaps less far advanced in doing profiling.
Sure, Mirjam, thanks a lot.
Okay, yeah. So there is another question about the canonical reference. Yes. So we have the canonical URL, and the question here is about the canonical reference. There is something called resource.version, and what is the significance of that? If you have the canonical URL, for example, again, for a patient. So let's say we have a canonical URL for an HL7 India patient profile. Then that HL7 India profile gets a version, and that would be that version of that profile. If I want to make sure that my resource conforms to that profile, I can also append that version of that profile against that particular at that particular canonical URL in order to indicate I conform to HL7 India patient version 1.0. But there are several problems with versioning, and several things that they have taken a closer look at. So there's also with packages, that you can just say, okay, I implement this particular package. But if on your resource instance it's important to indicate that version, then that will be done after the canonical URL with a pipeline and then the version number.
Yeah. I have one question on top of it. So is it possible that I can actually update, suppose I have a structure definition of a patient and say let's India patient, and I assign a canonical URL to it and a version associated to it. And now I wanted to do an update on that particular canonical data, right? I mean, like the same profile. Maybe I'm just editing some text on top of it, or I'm not doing any change in the cardinality, neither I'm doing any profiling on top of it. Do I need to do a version update on that particular instance?
Well, yes, it's of course up to yourselves, but it would be very useful to up the version number. So what we do usually is work with the semantic versioning numbers there, where if you have a major change, you up the first number. If you have a more minor change, it's the second after the dots, etc. But in order for people to really know what they are working, or more, it's more on the author side that you can see that you have made changes. Even of course they can't be breaking changes, otherwise you would create a whole new profile actually. But if you just make some typo changes or text changes, then you just change your version number on the resource profile there. I would do that, yeah. And that is why I do not really like the version number on the canonical URL indicating conformance to that particular version. Because as you said, if you just make small changes that do not implicate any implementations, then it's more of an authoring thing, that you know that this is a new version of your profile, and instead of an implementation thing that things have changed on that side.
Yeah, exactly, because there is some bit confusion over there, because as soon as I do an update on that, right, I mean, I would be actually instead changing the version into the meta.version rather than resource.version. Right.
I will have to take a look at that. It will be in the metadata of the structure definition, so that will be the structure definition version element there indeed. So that was that part.
We can use Mirjam, so we can also use structure definition.version. That's a business version of a structure definition.
Yes.
Yeah,
yes,
yeah,
that
exactly.
one.
So yeah, so that's what the question is. And do we need to do a change in the resource.version? Resource.version, I'm talking about the structure definition.version and not the, because meta.version, definitely there would be a change, right? Because that's an because it's a new instance. Oh, sorry, it's an update on that this one. I'm creating a new instance altogether. I'm updating it.
Yeah, so I would make a new version in the structure definition.version there, so you know that changes have been made from a business perspective. Yeah.
So Mirjam, one question before, and this is a question about the tool itself, the Forge tool. So when we create a profile using Forge tool, right, and then we use the HL7 IG creator, right, IG generator publisher. So there are two fields missing, like the ID and the title, right? These two attributes we had to add manually into the resources.
So let me just, there is this link, and I will just switch over to Forge to take a look at what you're talking about. Here's some online exercises if you want to do more with profiling, but it is on PDF as well, right? So let me just switch to the Forge tool to take a look at what you are doing. So I still have some time. It's I said that I had to leave at 7 p.m. sharp, but I do want to finish off this session nicely, so we can take a little bit over that if you need. So if I create my own profile in the Forge tool, yes, it will not have an ID. So let me just create a patient here. So you would fill in a name and a nice canonical URL, of course. So, okay. that will generate my patient profile. And of course, I can make these changes like the cardinality, etc. here. If I now go to properties, that would be the metadata properties of my structure definition, where we can find that version and things like that. But there's also something called resource ID. And is that what you meant? That is not filled in by Forge, right?
Yes.
Yes. And that makes sense because the resource ID is the technical ID that a FHIR server assigns to a resource whenever you create it on the server. So in this case, my Forge tool has not created this on the server. It's just local. So my resource does not have a retrievable technical thing yet. So that is why Forge does not fill this in. You also mentioned title, but I'm not sure where. Oh well, it's in here.
Yeah.
So
okay.
It is not a mandatory field. If it were a mandatory field, then we would have a little bit of a title in there already, or at least we have Forge indicate that this field has to be filled in.
Yeah, and
right?
this issue
So
is all. Yeah, this issue comes only when we do the IG publisher. The name of that profile becomes blank if we don't put the title, right? In
yes.
the IG
So
publisher.
you probably want to fill in a title, but in FHIR it is not a mandatory field. So that is why Forge does not fill it in for you. There are other fields in here that might really be useful for you, like the publisher field, contact information, copyright information, things like that are things that you as a profile author really need to think of. Usually in demos, I do not fill them in because this is just a demo profile and it doesn't make sense to do all the work. But if for HL7 India, you are going to create these profiles, then you want to fill in these things because you want to be able to, for people to reach out to you. You want to perhaps have a workflow that says, okay, any author creating a profile also needs to fill in that title. And if you then have a tool like the IG publisher telling you, or well, not showing you anything when you didn't fill in the title, then, well, that is an extra indication that this field might be really important to you, even if it is an optional field in the FHIR specification. So Forge has these fields. You can fill them in if you need to, but whenever it's not a mandatory thing, then Forge will not focus on that for you. So that's something that, well, you have experience now. And this resource ID, yes, that will only be there whenever you have published this to a server. So as soon as I publish this work to my simplifier project, it will get a resource ID attached to it, because then it is saved on that server, and then that resource ID will get back to Forge. I can show you if you want. I can just do a publish simplifier.
I understood that. I understood that.
Yeah. So yeah, so Forge is a tool to create structure definitions for you, but other tooling might need some extra fields being filled in.
True. Because what we were doing was we were just taking the profiles from the Forge and then trying the publisher.
Yes. Well, it should work. It should at least not break the tooling, but well, that resource ID, I don't know why they want it on there. It's not a mandatory field in the FHIR specification. It is only mandatory when it makes sense to be able to retrieve them from somewhere. So yeah, I don't know why they have an issue with that, but when you know it has an issue, you can either fill in an ID yourself, because this field is just, I can just fill in something like this, resource ID, and then I have a resource ID. So that is an option. Yeah.
Thank you.
Okay. So now I've lost my chat window there because I did something. Okay. So creating a profile is just as simple as opening up a tool, selecting a folder to work in, and then selecting that new profile to create that profile. But you can also, if you are on this folder here, you can also right-click on any other structure and then say new derived profile. This profile I've created previously in the Tuesday session with the Mirjam's patient, and it has 2 mandatory fields. And the nice thing about derived profiles is if I create one, you will be able to see the things that are already changed in that profile as if it were a normal FHIR structure. So now I have created a derived profile on top of my previous patient, and you can see that they have these mandatory fields here. So this is nice if you have an HL7 India patient profile, then other organizations can take that and say, okay, we are going to use that and create a derived profile and make extra constraints. But they can't make any mandatory things optional, as you can see here. In a normal patient profile on the base FHIR patient, it is set to 0 to 1, but in my profile that I've based on now, it is mandatory, so I can't just change it back to being an optional field. And of course, it has that advantage that you have the work that people have already done for you integrated in this particular profile. Now, we mentioned that human name, right? So this name here, it lists the type human name. And one of the questions was that target profile. Yes, you do not see it. Well, it's actually not called target. And that's always, I always make that mistake. A target profile is if you have a reference type field and you want the reference resource to conform to another profile, then it's called target profile. In this case, it's just called profile, and I can add to that. You do not see in FHIR4, you do not see the current profile, which is just the normal base profile actually. But I can fill in something like my own human name. Let's just make something like this. Mirjam's example, structure definition, human name. So if I had that and I put that into this profile part here, then FHIR will generate this in the XML, and you will be able to see that in the XML as well. If you look at the differences, you can see that the profile for the human name is now set to my own human name. If you want an example of other profiles and how they have done that, then you can take a look at SearchParameter. So what I usually take a look at is the ANAL-core profiles, because I do like the way that they have been set up. So you could take a look at those, and you can see right away from this list that we have the human name, we have the address, we have done some Dutch specific things on them. And let me just find the patient. No, let me just do the patient, the practitioner, that doesn't really matter. So for the ANAL-core practitioner, you can see that if you look at name, instead of listing human name, which is the FHIR data type, it lists ANAL-core human name. So this is the combination of a human name profile with this particular profile. So they've created 2 profiles for that and then combined them. And on SearchParameter, you can click on and then you jump to that human name, the Dutch human name data type, and you can see all of the things here. So the advantage of doing it this way is that we could reuse that human name data type that was profiled here with extras on the family and the given names. We can reuse that in the patient profile, we reuse that in the practitioner profile, in the person profile, etc. So they only had to define the name structure once, and then they could reuse that. But as I said, it depends on your particular use case if you want to do it like this, or if instead of doing that in Forge with that human name, you can of course also just do the restrictions on here. So I could just say, okay, family name is a mandatory field without going to the human name part there. So that is something that is a useful option, I think. So the Dutch core profiles, they are really good, I think, in structure. They have done a lot of work. And there's also the HL7 Germany. They have done a lot of work on profiling as well. And they are on SearchParameter too. So they could be 2 projects that you could take a closer look at and then see what they have done, how they have done it, and perhaps relate that to the HL7 India work that you are going to do. So are
Sure.
there any?
So one more question, Mirjam.
Yes.
You showed the Profiling Academy, right? Is that free, or how does it work? Can anyone go in there and practice?
I'm sorry, the profiling what?
The Profiling Academy, right? So there is a
Oh,
Profiling
yes.
Academy.
That is free, yes. So what we usually use it for, I also do the profiling training course, but then you could point people to the Profiling Academy to find out particular things in there. I don't know how well maintained that one has been, so I would advise this one first over going to the Profiling Academy at this point in time, at least, but it could be really useful. You can just go to that, I think, without logging in. Let me just check. I'm not logged in at the moment on SimpliFIR. As you can see, we are, it's empty there. So let me just click on that. It could be that you need to have an account, but oh, it works. So yes, so you can just go there and you can go and see about profiling, but we have also created that extra profiling tutorial where you have exercises as well. And if you go to the project containing this guide, which is just, I think it's just called Acne Profiling Tutorial, but if you go to that particular project, you will also be able to see a list of proposed profiles that are the solution to that particular tutorial that we have. So there's a couple of things here that we have created profiles for. And well, if you do that tutorial and then you check here what the ID was, I think you get a good idea of a couple of profiling aspects there. And then the Profiling Academy, you can just go there to find out even more.
If you don't mind, can you put that in the chat window, the link?
The link to
the
this
profiling one? Yeah, the profiling session that you said, the profiling tutorial.
Yeah, so I will just do this one first. This is the project.
Okay.
And then we also have, which is actually just a guide that's in there. And so that is this one. So the second link, that is the tutorial itself, and the first link, that is the one that contains the profiles that are a result of doing the exercises on there. Yeah, so feel free to play around with that. And I hope you have found this session useful. There are several people on this chat that have my personal contact details, so do feel free to reach out to me if you have any more questions, or if I can give you any guidance somewhere. I would be happy to help out. So yeah, just let me know. So HL7 India, thank you for inviting me and hearing me out today, and hopefully we will see each other in the future.
Thank you, Mirjam. Thank you for coming.
Bye-bye.
Thank you.
Bye.
Bye. Thank you.
Bye. Thank you.
Thank you.
Bye. Thank you.
Thank you, Mirjam.